We're going through exercise 13D, question 1, which is asking us to solve for x in each of the following. So here we have them all here. So let's solve for x. So when we're solving exponential equations, the first thing that we want to do is make sure that we have the same bases. So right here, what I'm going to do is go, all right, 3x. So I now want to represent 27 with a base of 3. And if I do that, I have to raise it to 3 because 3 raised to 3 is 27. Then I can equate my indices. So if for this to be true, x is going to have to be equal to 3. So I'm going to come grab my highlighter and give that a highlight. Let's now move on to the next one. We have 4x equals 64. Again, I'm going to make my bases the same. So that means it's going to have to be 4 raised to the 3 because that's 64. Now I can equate my indices. So I'm going to have x equals 3. I'm going to grab my highlighter and give that a highlight. The next one's a little bit different. We have 49x equals 7. Well, the first thing I can do is say, well, it looks like my base is going to have to be 7. I know that 49 is 7 squared. Now, don't forget about this x here. So this is going to have to be x there, equals 7. I know according to my third index law that I can go 2 times x. So it's going to be 7, 2x. Whoa, that's an ugly x. X equals 7. What I also know is that there is an invisible 1 here. So therefore, I could say if my indices are going to equal each other, it's going to be 2x equals 1. I then am going to rearrange to solve for x. So it's going to be x equals 1 over 2. So I just divided both sides by 2. And look at that, I got x equals a half. And that makes sense. If another way you wanted to think about it, you could simply go, well, I know if I square root 49, that's going to be 7. And the way I represent that as an indice is a half. That's another way you can do it, but whatever way works for you. Let's keep on going now. We now have D. So D is asking us this one. I'm going to give them the same base. Now, to give these the same base, I'm going to have to do something. I'm going to have to make the base 2 because that's the only way I can make bases the same. So in this case, this is going to have to be 2 raised to the 3. And this one is going to have to be 2 to the 4. And then don't forget, you have that x right there. Then this will be 2 for x equals 2, 3. I then equate my indices because my bases are now the same. So it's going to be 4x, that's an ugly x. Let me try again, 4x equals 3. And then I'm going to rearrange to solve for x. So I'm just going to divide both sides by 4. I'm going to get 3 over 4. Grab my highlighter, give that a highlight. Let's keep on going. We have 125x equals 5. I know that 125 is 5 raised to the 3. X equals 5. That's going to be 5, 3x equals 5. Remember, I know there's an invisible 1 here. So that means, because remember, 5 raised to the 1 is 5, so it's perfectly fine to write it like that. Then I'm going to equate my indices. It's going to be 3x equals 1. I then am going to rearrange to solve for x. It's going to be x equals 1 over 3. Grab my pen, highlighter, highlight that one. Let's keep on going. We're doing well. We have this one now. What are we going to do? Well, I have 5 raised to the x equals, well, 625 is simply 5 raised to the power of 4. So this one's quite an easy one. Then I equate them. It's going to be x equals 4. Not too hard at all. I don't know why they put that one there. That was a nice one. All right, let's keep on going. All right, we have 16x equals 256. This really comes into play of really knowing your indices and kind of just memorizing it. So for instance, I know that in order to make this work, what I'm going to do is actually make them both to the base of 4. So this is going to be 4 to x. And then on this side, that's going to be 4 to the 4. 4 to the 4 is 256. 2 to the 8 is 256 as well. So that's kind of how I memorize it. But whichever way works for you, just make sure you get to memorizing these things. Whoa, that's meant to be a 2. 2x equals 4 to the 4. That means I'm going to be left with 2x equals 4. Then I'm going to rearrange to solve. I'm going to divide both sides by 2. And 4 divided by 2 is 2. And there we go. So perhaps an even easier way to solve that is 16 squared equals 256. So obviously 16 raised to the 2 is 256. But I knew that in terms of 4, so that's how I did it. But again, you could have done that a different way. All right, let's keep on going. I know that this can be represented as 1 over 4x, and then this is going to be 1 over, now instead of 64, I'm going to write that as 4 raised to the power of 3. Now I can equate these indices, so it's just going to be x equals 3. Lucky last, I'm going to do the exact same thing. 1 over 5x equals 1 over, this is simply 5 raised to the power of 3. So I'm going to equate these indices. So it's going to be x equals 3 again. I'm going to grab my highlighter, give that a highlight. And now I'm going to zoom out and appreciate all my work. Whoa. All right, wait, there we go. There's all my work right there. Hopefully this was helpful, and remember, if you are struggling with this, consult your section summary, which clearly tells you that one method for solving an exponential equation without using a calculator is first to express both sides of the equation as powers with the same base, and then to equate the indices. Hopefully this was helpful to you.